Here we're seeing the graph of a function f of x, and we want to know what cannot be true. Look at this carefully. Now remember that f of x represents the y value. Well, look carefully at this graph. We get this problem on two counts here. One, if you look at it closely, look at the lowest points. Y never goes negative, so you can't have a y value that's negative. And if we look at our answer choices, we also know D is correct because it's different. It's the only negative one down there. We kind of point to it. That's the hint we get. So the value here that cannot be true is D. We can't have a negative value for y. Okay, this is a function problem where we're going to be substituting. If we look here, we say f of x equals x minus 4. That's the value for f of x. And we say that 3f of y equals 18. What's the value of f of 2y? Looks real confusing, but just take it one step at a time. First, we're going to have to solve 3f of y equals 18. We'll substitute y minus 4 in there for the y value, for f of y. And we get 3 times y minus 4 equals 18. 3y minus 12 equals 18. 3y equals 30. So y equals 10. But now we want to solve for f of 2 of y. Well, y is 10. So 2y would be 20. So we're looking for f of 20. Well, f of 20 would be 20 minus 4, because we put it back in that same equation, gives us 16. Okay, this is a pretty tough problem. We've got the graphs of f of x and g of x in the figure above. And we're shown that f of x is equal to x squared, g of x is equal to h minus x squared. And we've got to get the value of h. Okay, we look at what they give us. They tell us that the functions intersect at the y value of 9. In that case, that means that x squared equals 9. So if we solve for x, we can see that x is equal to negative 3 and positive 3. Okay, now we're going to substitute that into our g of x equation. And g of x equals h minus x squared. So substitute the x value of 3 in there, and we have that 9, because remember that g of x is the y value. 9 equals h minus 3 squared. So 9 equals h minus 9, so h equals 18. Here we have a graph of two functions. One of them, f of x, equals x squared minus 4x. The other one is g of x equals f of x plus m plus n. M and n are constants, and we want a value of m times n. Remember this with functions. Functions, when they move, when you add or subtract to the x value, and when you add or subtract to the y value, you have a kind of counterintuitive situation here. When a function changes on the y value, when it moves up or down, it does what you think it does. When you add or subtract to the y value, which is what we'd be doing with n, when you add or subtract to the y value, it does what you think. If you add, the function moves up. If you subtract, the function moves down. It's counterintuitive on the x side, because if you add or subtract to the x, the movement's different. If you add to the x, increase the x value, the function moves to the left. It moves negatively. If you decrease x, subtract from x, the function moves to the right. It moves positively. It's counterintuitive, but that's the way it works. So let's see how this moves. Well, we're going to move in the x value from 0 to 4. So that's a movement of 4. It's a positive movement of 4, but on the function side, that means you're subtracting 4. Now we move on the y-axis from 0 to negative 3, and remember that goes the way you think it does. You're subtracting 3 from it. So what we've got here, when we multiply m times n, is negative 3 times negative 4, which gives us positive 12.